Many specific problems may arise. Many have their solution thanks to the magic drawer accessible through a discrete vertical dotted area on the right of the software. Click and or drag on this area. Once the drawer is open, we have two tabs: Local to modify a sample and Global to modify all the sample at the same time. There are also two management modes, Normal and Advanced. The Normal mode allows to modify the detection threshold only. The Advanced mode allows to modify many detection parameters, threshold, to make patches, analysis of region, smears, etc. It also makes it possible to force the calculation of the RNA integrity number, or RIN. One or the other will be used according to the problems encountered. We will describe the most frequent. A visible peak may not be detected. A lower or upper marker peak is well detected as a peak but not recognized as a marker, which affects the alignment of the profiles. In addition, it is quite common that the RNA integrity number, RIN, is not calculated. One can encounter problems of identification of the two major peaks of ribosomic RNA, which disrupt the calculation of the ratio and that of the RIN. Finally, entire region can be identified. Some useful peaks are not detected. In this example, the profile of the ladder is very beautiful, but the control peak called lower marker is not detected, although present. The lower marker was therefore mistakenly assigned to the first peak of the ladder. Indeed, the peak is low and probably below the intensity detection threshold. Evaluate approximately its intensity in FU. Here, 2. Go to the setting area, the magic drawer, and the local tab. Then, in normal mode, lower the value of the height threshold FU below the undetected peak value. So in this example, below the value 2. Click on the Enter key to validate the new value. Observe the detection changes on the sample. The peak is now well detected. Sometimes peaks are detected but are not recognized as control markers, lower or upper marker. The line corresponding to the lower marker peak must be marked with a green triangle, which is not the case here. While the line with the green triangle is incorrectly assigned to the first peak of the ladder. To correct this problem, select the right line, right-click and select the action manually Set Lower Marker. The lines show now feature the green triangles. The profile of the ladder is now corrected and aligned perfectly with the samples. Sometimes the RNA integrity number, the RIN, is not calculated automatically. A red dot appears on the RNA profile. When an RNA is degraded, has a very low concentration, or has an atypical profile, this is normal. But sometimes, for various reasons, it is necessary to force its calculation, even if the RNA is beautiful and conforms to the standard. First, at the bottom of the sample profile, go to the Error tab and note the type of error reported. Here, in this example, the error is unexpected baseline signal. Go to the magic drawer in the Local tab, and in Advanced mode, scroll down to the RNA integrity number. Locate the parameter corresponding to the error found on the profile. Here, for example, baseline anomaly, and increase the value of this parameter by about 10%. Confirm by clicking on the Input key and see if the RIN is now calculated. If the first correction has not had any effect, increase stepwise until the desired result is obtained. Here is an atypical RNA profile. Let's go to the Result tab. Several problems appears. 1. the RIN has not been calculated. 2. The ratio 28S, 18S is equal to 0. Let's go to the Fragment Table tab. We see that an 18S peak has been identified with a correct delimitation of the area under the peak by a pink line. A green line named 28S was also created, but the boundaries are not well placed. This defect can be corrected like this. Just grab the end of the line with the mouse, slide it to move it to the right place and release. Now the peak 28S is properly defined. If we go back to the Result tab, the ratio has been calculated. This information is important because it reflects good RNA quality. Let's go back to the Fragment Table tab. In some cases, it may be useful to add an RNA population. To do this, open the Magic Drawer, select the Advanced mode, and get down in the RNA fragment part. Double-click on Table. A window appears. Click Add and refine a new RNA population such as my fragment. Enter the approximate sizes and click OK. On the profile appears now a new line called My Fragment. That we can move to adjust to the limits of the peak of interest. This fragment represents a certain percentage of the total and can therefore be quantified precisely. So far, we have seen the identification of well-defined and sharp peaks, such as lower or upper markers or ribosomal RNA peaks. But the system also allows the analysis of regions or broad smears. In the lab, we use it mostly for DNA profile like this one. To define and quantify the regions of interest, open the Magic Drawer. Choose the Advanced mode. Go to the Smear Analysis line. Check the Perform Smear Analysis box, which immediately creates a new tab at the bottom of the profile called Region Table. Click on this new tab. You now see two vertical lines framing a region. Their positioning was established on the previously used parameters. You must adjust their position on your profile by dragging them with the mouse. Once the region of interest is well fixed, you can know the time of migration, percentage versus total, concentration in nanogram per microliter, or nanomolar.